So welcome everyone to a developers meeting on Sunday the 16th. I have to look it up. Yeah, and I want to kick it off with a question, if you allow me to. And this is the definition of the alpha version. Because I saw in the Discord that we have several discussions that are going in, let's say, various directions, and I think it's a good point in time to, let's say, summarize what we're focusing on right now. So just to bring everyone on the same page. Who wants to kick it, Ido or Christian?
I'll
Where's
start, I guess.
Christian? Oh, Christian just dropped out just the right time. Ido, that leaves it up to you.
So, so, Christian, just because you came back, the question is, what is the alpha version?
Yeah.
And you and I spoke like a lot about it, like what we want. And there are two pieces to it, right? Like the goal for us really is to achieve like a workable station with all the parts in it, right? But all the components on a very low maturity level, I would say, right? However, when I think about like an alpha version, I think about like, what we discussed earlier, and this is like really like the all sky camera and the tracker working, right? And then it can be even partially working, but what I really want is to start getting it out there, get feedback on the recording, everything starts stabilizing whatever we can, and then move to the next step, which is from the tracker to the telescope, right? And that. So even if we get out that it's barely working, like a barely working robot, right? That's that's the call, like as soon as possible. And after that, it's beefing up all the robotic parts, improving the performance, make it stable, make it nice installer for all of it, adding the security, authentication for the video feed, and so on, right? But with all of that, we still need, between us to kind of discuss what we put on like the project plan, how we gain focus on that, because I think that's missing. I spoke with Rebecca earlier this week, and I suggest we can just use GitHub Issues, because you can have all the you can put the alpha version there, what's inside. We can discuss the issues there if it should be included in alpha, exactly like any other open source project. So that can work very, very well. It also will allow the community to provide us feedback just by creating issues, like, is this camera supported? Is that camera supported? This doesn't work properly, whatever. We will need to start monitoring that, provide feedback, prioritizing, and answer. So that's my take.
Mm-hmm. Okay, thank you. I just throw in some questions that comes out from that. So first of all, we have the fisheye camera, which is now defined. It will make use of a PI where the pre-processing of the stream is handled, and then it will be supplied as ROS2 messages to, let's say, another device where the tracker is, for example, running. Okay, so just information for all of you, ROS2 will be the main communication element here. So that
transport protocol.
Okay.
To be more, or the system of system kind of for the station.
So the idea is that the whole station is actually kind of a robot. That's why the robot operating system, and it makes a node, a robotic node out of every sensor, basically. So every sensor is running for itself, and when it's called, it delivers. Okay.
Yeah, so, and it receives commands and notify statuses.
Okay, you can also via ROS commandeer it, let's say, send it other commands that should change its
Yeah.
behavior, for example.
Yeah, and on top of that, for the QHY camera, we're going to utilize the Indy server coming from astronomy. And that's coming with high precision and all of the accuracy that is needed, right? So that's kind of the next step. Right?
Okay, so let's assume this is a communication between the tracker and the Pi, receiving the stream and processing it in the tracker. Just an example here. The tracker finds events and tracks them, monitors them over time. What is now the purpose of these tracks? What is the next step to what part is now working on the tracks or receiving those tracks?
Yeah, so once we have tracks, right, we need to prioritize them, and then we need to automatically start slewing the telescope, right, for for the second video feed, right?
Yeah. So this is future talk,
yeah.
because the PTF will be next year. This is our focus on next
year.
But for the alpha version. For the alpha version, there's the camera feed from the fisheye, and there's the tracking. Will we record these trackings locally?
Well, definitely we will. I don't know if for alpha version it will be needed. It could be just for fun, just to display an alert that you get on your phone or something, and then someone can go look at the sky. But again, I'm thinking very minimalistic here because we want to get the stuff out there, right, and more iterative, and get the feedback from community for improvement. But like shortly after that, we'll be able to record. Like we are going to build a real-time recorder for the tracking, the videos, whatever.
Okay, so the focus is first to have that stream, that pipeline from the fisheye camera to the tracker as quick and performant as possible. And I know it's about color depth of the image, and it's about FPS, and
Yeah, so here is where I will tell you, even FPS are not important right now. Making it working is important. We can always improve performance. It's a never-ending user story, so to speak. Okay.
Yeah, it keeps us busy for the next 10 years.
Yeah, improving reliability and performance is something that never ends.
Yeah.
Okay. That's why get it work, and get to the point that we need to make it better.
Now a question on the side. Rebecca, for example, is there a chance for the alpha version to have something visual too, so that there is kind of a service that what happens on the tracker is somehow visible?
Well, Magnus is working on the video feed. So I think it's going to be based on his progress. But yes, we'll definitely, for the alpha version, I have the video feed from the camera as well as the PTZ once it's available. And then also what do you call it? The camera mask. The camera mask is finished. That's finished. So we're waiting on the camera feed / media player. So we'll need to have the feed written up and sent through ROS2 and then fed to the camera media player. And Magnus is working on that. And so those were my goals for the alpha version. From what I understood, that was what we're going to have for the alpha version. And so it's pretty much underway. I already have a ROS2 and a GUI hooked up together and communicating, but I'm going to actually convert that to Node.js. But if there's not enough time, we still have just a basic HTML page that we can use to render the video.
Okay, HTML5 probably. Okay.
Yeah. And so I've been writing all of that up, and I'm going to do some tickets, but the alpha version is already being worked on right now. And so it's basically dependent on Magnus. I don't mean to put pressure on him. I know what he's doing, very detailed. So but that's the status. So the alpha version is almost ready to go. And the idea is there. It's now just a matter of putting it into action.
Yep. Okay. Ido, you wanted to say something?
Yeah, so that's like on software side. On hardware, we still need the adapter, Christian.
Yeah.
Waiting for it. And the camera needs to arrive so we can start punking with it.
Yeah, so Oliver's here too. We printed the adapter with several materials.
Oh, sweet.
It is a high precision part, and to make that 3D printable and agnostic of different printers and material, we are still printing some samples and doing adjustments on the printing way of how to print it. There are so many ways to do it, and good ones, bad ones, long ones, short ones. So we are still in this prototyping phase. So yeah, it is still, at the moment, there's an issue with the centricity of the camera, right? Not the fisheye is perfect centered. It's the camera where the centricity is not perfectly aligned right now. So Oliver is now going back with another nozzle and printing, and yeah, it will take 1 or 2 more weeks, I assume.
Okay.
Until we have that.
That's fine.
Yeah, and this, I mean, we're talking about 3D printing here. Oliver can do this, let's say, for Europe, but we need to find someone who can print stuff for the US. So if anyone comes up with, I have 2 or 3 printers in my home, please send me a DM, for example. And yeah, we need help in the US, 3D print help.
I can print at my home, but I have a mini, small and slow.
Yeah, there's one part that's a little bit bigger. We need a little, at least 30 centimeters on one part, for example. That's the door inlay for the first 15. Later on, we don't need this anymore, but this one part, particular one, is a little bit big. I want to come back to the media player. Magnus, do you hear me? Magnus, I see you unmuted, but still, can you, Ido, can you hear Magnus?
Yeah, we can hear him.
Ah, okay, I have to step out again.
Come in for a 3D printer.
It depends what you want to do. If you want to print huge things, you can go for Creality CR10 Pro. I think it can print up to 45 by 45 centimeters, but has no enclosure, so ASA will be a challenge. If you're fine with smaller things, you can go for an Ender Creality Ender 5. It's high precision. You can print anything, but you have to build an enclosure too, or anything within 100 and $1,000.
What? But don't you have a recommendation for what size that we're working with here?
I have 2 printers. One printer is the Arnet A8, and I pimped it like hell so I can print industrial grade materials like Carbon X with nylon to peak. These are materials that cost from 150 euros to 450 for one spool. Yeah, it took me about, let's say, 150 to 200 euros to pimp it like that, with a new power supply and a nozzle, the Olsen Ruby nozzle for adhesive material like carbon. But you can use the Creality or 10-log, whatever you like. You can pimp every one of them. Just use another nozzle, maybe use another power supply that provides much more power. You can modify the heat bed so it can use 24 volts up to 30 amps, so you can reach temperatures between 150 to 340 degrees only for the heat bed. Options are unlimited. Take what you can get your hands on, and you can modify the things. So a normal printer, let's say around 300 to 500 bucks, can print PETG, ABS, and ASA very fine. So these materials do not have any problems. But if you want to go for carbon-based materials, which are much lighter, have features like steel, it would be good having another nozzle and a different heat bed. But the rest can stay the same.
So this was not much information. I'm not sure whether Dominic could consume everything. The question was more what printer
it's recorded, so I'll go back. It's recorded, so I'll watch it.
I'm not sure you can do anything. Let's talk about 3D printers any other time, because it's as Christian said, you can probably take anyone. But just to make things easy for anyone who wants to print material with us, is we have indoor, so let's say in the enclosure equipment, which is, you can take any kind of material. So you can take BDP or even PLA or what have you. But when we use parts on the outside, there is a real limit on the material that can be used there. And the one that we all use for outside material, like the adapter in the fisheye, underneath the fisheye dome, is exposed to sunlight. So there's strong UV light on that material, and UV is, besides temperature, but UV is a killer for plastics. And so we recommend using ASA there. So either ASA for the outside or anything else on the inside.
Despite PLA we do not use, because it has issues with temperatures up to 60 degrees, so it deforms, and we do not want that. So we skip PLA at any case, but PETG, ABS, ASA, they are all fine.
All right. I want to come back to the topic of the media player, Magnus, you are working on. Can you hear me now, Magnus?
I can hear you. Can you hear me?
I can hear you, finally. Thank you.
Good.
I hope you're doing well so far.
Yeah, at least better. I've had the goal to have a first version finished by, I think, last weekend, but health issues got in the way. But I'm better now, and I will have some time this week. Finished up. I have the big parts ready. I have to finish it up and connect them, so to speak. And since we haven't decided yet how the images will be delivered, I've disconnected that code-wise to be able to plug it in later when we have a specification of how the images will be received from the camera or from ROS2 in a ROS2 message. So meanwhile, to be able to test, I made up what I think it might look like. So I think it's it's a mock type of message. So well, I hope it will be okay very soon, and as soon as I'm happy with the solution, my plan is to contact Rebecca, and she and I can have a look at it together, is my plan, if that is all right with you, Rebecca. And we can see how we should integrate it into the other client solution that we have, and get things working together.
Okay.
So that's overall quick status.
Okay, thank you. Hey, Magnus, a question to the media player itself. What media player are you using right now?
Well, it's actually it's a WebAssembly component in the bottom that stands for the decoding and for the controls of the video. So it's not a program. It's a component. So yeah.
Okay, and so you don't get videos. Sorry, this was my mistake. You get images, fired images, 1, 1, 1, 1, 1, and so forth, right?
No, it compresses them to a stream, and so for the user, it's a movie. It's media, but yeah, but since the camera delivers the images one by one, it has to be put together on
to a stream.
Yeah, exactly.
Yeah. So that now you are playing back, you're rendering a video stream in the user interface. What method do you use there?
To create the video stream.
Yeah. No, not to create the video stream, to play it back. Are you using VLC or HTML5 methods?
No, yeah, HTML5 method. It's a component built on HTML5, and it's a WebAssembly component that is loaded in the browser.
Will that component allow for let's say frame by frame play, or all these features like quick forward, backward, and so forth?
Yeah, it has all the standard features of a video player for VLC, for an example. So that I think that will be useful.
Besides, I never came about a VLC implementation that can do all what VLC is supposed to do according to the API. No one is using these features, and I was wondering whether these features do really work with VLC. I mean, the VLC player itself cannot play backwards, for example. Why is
no,
it
but the FFmpeg in the bottom of VLC is super powerful. I don't know exactly all the features what it can do or not, but it's a real powerful component there. So, but
I have a question. Do you know if does it play frame by frame as well?
I can't tell you that if it's possible to do that.
Look, I'll make it simple. We are getting into a niche that we need to avoid. Okay. Mm-hmm. For now, even play and stop is fine. We have nothing. Let's start simple. We can always add more buttons, and even if it's needed and FPGA doesn't satisfy us and it doesn't have rewind, we'll find the time to make it happen. Okay. Right now, we need to get to a working station.
Yeah, that's a good point.
So minimalistic player, I would say it's okay. Even if it's just displaying and I can just stop it. Okay.
Yeah, basically you're right.
Let's get it there. Let's see it. Then we'll provide we'll have something tangible to play with. Yeah. So we can have further feedback.
Yeah.
Okay.
Yeah. Okay.
Yeah, that's cool.
Was my private question.
We are all engineers. I fall into this trap all the time.
Yeah, I'm trying to find some feature list or something for the component I'm using.
Yeah, but WebAssembly is good. What is it written at? Just my curiosity.
Sorry?
What is the web? Is the WebAssembly you wrote it, or it's like something you download and compiled?
No, it's a component. It's a Blazor video component. So.
Okay. Do you have the open source for it?
Yeah.
Is it open source? Yeah. In which language?
Sure. Guess it's. We'll see. I can check it out for you.
Okay.
I guess it's a mix, as it usually is. Let's see. It's written in C# and Smalltalk mostly. Yeah.
Ooh. Okay.
Yeah.
Okay, that's fine.
All right. Hey, Magnus, last question concerning GitHub. Do you have access now to GitHub?
Yeah, I sent you my my account today. Did you see it?
Yeah, I did it. I added you already. So,
All right.
You didn't check
I
it.
think
okay.
I think I already had access. Or I'm sure I had.
I couldn't see you in the list of members, so I couldn't add you to a team.
Okay.
So maybe you can recheck again.
Yeah, I will check it again.
Okay.
I'll get back to you. All right.
The same is true with you, Michael.
What?
The ghost, Michael.
I'm sorry. I looked like I got added to your GitHub. Is there something else I needed there? And I also saw where there's some shared documentation folders and things like that for me here middle of the week.
Okay, and, so you're already on GitHub now because I didn't see you today.
Yeah.
Okay.
Well, I'm not signed into GitHub at the moment. No.
Not in the moment, but you have access now. That was my question.
Yeah, it appears that way.
Okay, perfect. Yeah. Check mark. Yeah, just another.
If I do have any.
Sorry.
Oh, I was saying, if I do have any problems with it, I'll let you know on DM.
Okay. Perfect. Just an information for all of you. I will add another team. We call it the audio team because we have some requests of developers who want to go into this realm. And there is Joe from Sydney and Bojan from Florida. And I hope, and he's not here today, and that's a sad thing. I hope that we will show up today. It's David from Scotland. He's an audio specialist, an expert, and that will be the new team for audio stuff. But yes, Ido, that's all for the future. It's nothing for now. No worries.
No, that's okay.
But people want to test equipment.
It's ready, once it's ready, we can integrate it, and it's going to be part of the next version, so it's fine.
Exactly.
It's all robotic parts. Yeah.
And I think it's good that we have several teams work concentrating on their parts, and whether it's only hardware for now, maybe it's then software in the future, and then it will be integrated somewhere in the future. But I think it's good that we start somewhere in time with such things.
Yeah.
Because things hardware side take times anyway. Okay, last question to all of you. GitHub per se is configured correctly for all of you, or has anyone issues? I think, Mike, you had an issue today.
Yeah, but I'm not. Yeah, we're still trying to figure it out. Really, So I think if you could just give me at some point, I'll email you, I'll DM you, and we can sort it out. There's something not quite right set up on this repository, which I'm just trying to understand. That's all.
All right. Okay. Yeah, let's find that out.
I don't think it's anything. Okay. I think it's something I probably set up initially, Richard. So it's nothing you did. In all fairness, it's probably something I did. So don't worry.
Okay. So if you want me to do anything, just give me a note.
Will do.
Okay.
Thank you.
Perfect. One note for everyone is, as you already know, Michael was as kind as to go on with the documentation team, let's say. So the idea is that Michael is doing an interview with all of you. He reads your papers that you already have written, so he gets an idea what your perspective of your project is, and he will summarize all of this. And there's Yannick. Where's Yannick? Oh, Yannick dropped out. Okay. That makes it hard for me to cope with you if you drop in and out. Okay.
Well, Richard, if I might, real quick.
Yes.
Yeah, I just want to say just fast status, just so everybody knows. I'm, prior to contacting you, I'm actually busy drowning in what's already there, just trying to get read in and up to speed on it. So, but yeah, the plot is to start reaching out to people. Probably not this week, coming up the following week, something like that. Because it's I don't want to put it. It's a lot. The way it's done so far from documentation looks great. The catch is it's a vast and complicated kind of interlocking bunch of subjects. So I'm getting that all straightened out.
I lost him. Christian, do you hear him?
No, he's frozen.
Okay.
Now he's back on again.
Yeah, he's back again.
Michael, you're there? Yes.
Yeah, I'm here. What got missed, I guess, would be the question.
Last sentence.
Okay, I just want to say, just to let folks know that, yes, I'm wading through a lot. I'm also on my least reliable link today because for some reason I couldn't get a hookup on the more reliable one. So anyway, so like I said, I'll just, let folks know that, yeah, probably not this week, but next, I'll start reaching out to people and see if I can't, aid and abet here a bit, So anyway, just like I said, that's status on that.
Okay, thank you, Michael. So I've got all my points on my list.
I've got one point.
Yeah,
any feedback about the talk from last week with Pierre-Luc? Any questions? Anything you want to say? How it went? What you learned from it?
So I can probably give you guys an update as to what's been happening on the side, if that helps.
Mm-hmm.
Go ahead.
Yeah. So okay. So after the meeting, I think quite early, beginning of last week, we reached out to Pierre-Luc and started discussing basically the vibe background subtractor. So he had already done an implementation of it, and he had done an implementation of it, which he kind of let us know about. He then set up a bare bones project for us to re-implement it. I've not done anything. So for Fabio to re-implement it. Fabio has done quite a bit of work this week with re-implementing it. I think he used it as a base version and then has been trying to improve it. And I kind of don't want to do an update on his behalf because I think he's done really well. But he's been working on the vibe background subtractor and has made some really good progress. We're just at a stage now where we're trying to get a pull request back into the main branch of our repository, but we're just struggling a little bit with that. And I think that's down to like a GitHub setup somewhere, so some sort of config option, which is the thing I need to message Richard about. But yeah, essentially, Fabio's been working on the vibe background subtractor and improving performance, and I think also just baselining, just also trying to understand, just getting to grips with everything. I think it's in a position where we can do like a first draft, and then we're just going to see how the next thing is to see how to bundle it into a Docker image, into one of our existing Docker images, so that it can be exposed to something like Simple Tracker, so we can kind of just play with it, with a eventual view of creating a ROS2 Docker image as well. That's still on my to-do list. I'm sorry, I haven't got to it yet, but that's still on the to-do list. But essentially, that's sort of where and that's all that's happened this week. So that's kind of where we are with that, really. So it's been there's been a couple of emails back and forth between us and Pierre-Luc. So Pierre-Luc. So it's it's moving forward. We've not heard from him this weekend, but it's weekend, so I'm sure by next week there'll be an update from his side. I suspect he would want to review what Fabio's done, comment on it, and that sort of thing. So it's great that I think it's fantastic that we have someone that I think it's a really good position to be in personally.
Yeah, and
so
didn't Pierre-Luc also say or write that he is doing an implementation of a background subtraction for us? Or can you help me here? He's going to prepare something for us. Can you go into detail?
So that was essentially that was the baseline project. So basically he put together a repository that was just really bare bones so that it could take the Vibe background subtractor. So it's basically like putting together a project in a source code term, which Fabio can then use to start developing the background subtractor. So that was quite early on in the week, and I think that we got that into the Sky 360 repository quite early on. I think it was Tuesday. I think I forked it into from Pierre-Luc's repository area into the Sky 360 repository, and then Fabio's been working on it since then, really.
Okay.
I think there's still it's like the initial draft. I'm not a C++ guy, but I had a quick look, and it looks like he's implemented the OpenCV interface and all this sort of stuff. So it's something that we should be able to. I basically put a question to Pierre-Luc as to whether this is something that we want to merge into the BGS library for everyone to use, or if this is something, that sort of thing. So I don't quite know how those guys want to move forward with that. But it does look like it implements the OpenCV interface. So again, it's going to be something that we can just use, and just use via configuration, really. Does that make sense? Sorry.
Basically, yes. My question will be towards Christian, maybe, or Ido. Please correct me if I'm wrong. From the meeting with Pierre-Luc, my takeaway was that to use a background subtractor like Vibe at the pre-processing stage, where the data from the camera is captured, reduced, optimized, and what have you, and then a background subtractor runs over it and creates only events that are changes in background from the previous ones, in a way so that the stream that finally goes out of the camera is heavily reduced to only events. Is this now true, or am I totally on the wrong path here? Christian?
For the first alpha version, and I think we will keep it more than enough time around for the first alpha version, we're going with doing the software part like Fabio and Pierre-Luc are doing it at the moment. And later, we try to put it into hardware, that the hardware is doing it itself. So everything that is developed at the moment is not lost. because we then take these algorithms, these implementations, and transform it to be done in hardware. But we can't do it now because we are focused on finding the right concept to do the reduction stuff and getting things out, getting along with ROS, and this takes a lot of time. And I think it will take some time plus, let's say, some additional weeks, but afterwards, let's say in a year or two, when we have got the time to transfer it, that it is done by hardware, these things will come in handy because the algorithms are already there. And at the moment, we're doing it by software, step by step, after the other, till we have a working version.
Yeah. Okay, you were talking about, let's say, a firmware directly running on the camera's hardware, right?
Yes.
Okay. But there's a second step, which is the PI, which does more or less the pre-processing of the material from the camera and delivering it as a ROS message, right?
Yes.
That's the second one. And the third point where a background subtractor could be used is the tracker itself, where it is situated right now. So my question is, do we go as it is with the background subtractor as a pre-process to the tracker, or put it on the PI?
I would say if we run it on the Nano, then it would be a pre-process of the tracker. And if we succeed in breaking it down so it can be run as a pre-process for the data reduction part, then we would have to run it on the PI. Yeah. But first, let's stick to it and run it as a pre-process for the tracker.
Okay.
Because we do not know how fast we can get the images or the data out. Okay. So we shouldn't focus on that first. First, let's get the data out of the camera. And therefore, the right order would be that it is the pre-process of the tracker.
So meanwhile, Fabio came in. Hi, Fabio.
Yeah.
Fabio, can you hear me? Okay, so yeah, let's give him some time until he finds his headset. I'm asking this question, Christian, because Fabio, now he is here, he can tell by his own words, already implemented it on a PI, and he had a reasonable performance increase on Vibe on PI. So if he already solved it and created, maybe he can create a ROS2 node for the PI doing background subtraction, if that is in the pipeline or not.
I think, yeah, so personally, Richard, I think we're kind of jumping the gun a little bit. I think, okay. So and the only reason I say that is I think the Vibe background subtractor is an option, and we need to test it and determine whether it actually performs how we think it's going to perform. So before we go down the route of saying, yeah, we're going to implement the Vibe background subtractor and, make it run in the PI and, as efficiently as possible, I think we need to just compare it with some other background subtractors. You know what I mean? So,
yes. I will make it even simpler than that, okay? Let's remove the PI for now. Let's remove the Nano for now. Those are hardware. Those are not important. Okay, for now. Okay. What is important, if you speak about comparison of the background subtractor, is actually the ability to do simulation, which is a replay of existing videos that we have to the tracker, right? And test it with different algorithms, right? And that can be an entire, again, ROS2 kind of nodes that we can build to achieve that. Right? Bear in mind that ROS itself already has the plugin that allows you to see the videos. You know that, Mike. You played with it, right? And you have all of these components in place in a way.
Yeah, so I haven't yet. No, so everything on ROS2, so everything that I've done on ROS2, I've done on ROS2. I've not actually leveraged any component that is currently in, and that's in the community. That's purely just because I was trying to get a better understanding of ROS2.
Yeah.
So,
okay.
Okay. So yeah. So I am busy reading a book on ROS2 at the moment, and that highly suggests that you leverage what is currently in the community and all that sort of stuff. So
yes.
it's on my list. I just haven't quite got there yet.
Yeah, the principle of ROS2 is don't reinvent the wheel. Use what we have in the community, and if it doesn't exist, contribute right to the ROS2 platform, which is exactly what we'll do. We will eventually have our own Sky 360 kind of ROS2 nodes, right? That are open source, and everyone from ROS2 can use them if they want to. Okay, cool. But what's important is maybe focus on the simulation side, like a replay of a video, and make sure that we can test different algorithms. Because that will save a lot of time in the future.
Yeah, so the replaying of videos, that's fine. That's already that's already there.
Cool.
The big thing to do now is back to putting together a Docker image that contains all the stuff for ROS2, like I've done for Simple Tracker. So basically, it contains a version of OpenCV that we've compiled, which is CUDA enabled, potentially CUDA enabled, a version of the BGS library that we've compiled, and and then some of the background subtractors that we are working on as well, be compiled, and all, so that's that's where I need to get to. I just haven't quite got there yet.
Okay. So if you have the commands of how you compile everything, I might have time this week to help on that.
Yeah, no, that's fine. Yeah. So thank you for the offer. That would be great. It is. So what I did previously, I've got to try and get this right now. I think I tried to build on top of the ROS2 image that I currently use, and that didn't work. Or I think I added those commands at the end of it was the final overlay of the BGS Docker image, and that it didn't work. So somewhere there's some components that I'm missing or not installed, or something's not quite right. So it's basically, I think it's going to just be a bit of hard work, kind of going through and just working backwards from the base Docker overlay and determining what needs to be added and removed.
Yeah, so for base Docker, use the one that we have on the DevBox repository. You have a ROS2 base Docker there that is up to date with the latest version.
Yeah, but it's also I need to have a CUDA version with the CUDA toolkit and all that sort of stuff installed.
Yeah,
so
we can add that to the so we can add that to the Docker. There is a Docker file that you build, and that will give you an image, right?
Yeah, so I've just basically I took the one from NVIDIA. I took the CUDA Docker image that I depend on is the one from NVIDIA. I can't remember. I think it's a 2204 dev, something like that. But so that was basically my starting point, just to get the stuff working currently. I'm not saying that's what we should use. I'm just saying that's kind of what the one I used before.
Yeah,
so,
that's fine. That's fine.
Okay.
Okay, cool.
So yeah, so that the big thing is still trying to get this Docker image up and going with ROS. So yeah, that's something I need to. I have been making some improvements on the ROS2 stuff that I've been working on, but yeah, it's the ROS2 Docker file that needs to be done.
All right. Fabio, can you hear us now?
Yeah, I can hear you guys.
Just going to ask something.
Yeah, go ahead, Rebecca.
So the gist of that conversation is that you just need to tweak the current existing ROS2 build to work with what Sky 360 is doing?
I don't know, Rebecca. So I tried to do that, it didn't work. So I don't actually. Yeah. So I'm gonna have to just knuckle down and kind of work through it, and one step at a time, really. So I don't know is the honest answer with you at the moment.
Yeah,
Okay.
like we need to use our own Docker file in the end of the day. So and rebuild everything from even BusyBox or whatever. So that's fine. Just get to work, and then once you get it to work, let me see it, and I'll fix it, update it, whatever.
Okay, cool.
Make it more like Sky 360 compliant. Okay.
Mm-hmm. You are a compliance officer now.
Yeah, I care about compliance a lot.
Hey, Fabio, I think we can now finally talk, right?
Yeah, we can.
Okay, here we go. So you made some, you already got the point. We are talking about backward subtraction and implementation here and there, and that we have to test in the future several backward subtraction that we find the right one for our purpose. Mike has now did now work with backward subtraction. You implemented the vibe. Can you give us, because you posted on Discord and maybe not everyone has seen that, can you give us just your experiences that you received by now?
Sure, of course. What I did was get the code from Pierre-Luc and for the vibe, and then I got his code, and then I just optimize it for as much as I can. That means I made it very tailor-made for performance. So it's like you have to make sure that we do some things before, because when we build a code for a library, we usually add a lot of more stuff there because we don't know how it will be used. Mm-hmm. Okay. So in my case, I removed some of the checks and a lot of the things because I know how we're going to use it.
Yeah.
And I also tweak it because to be very streamlined and very straightforward for us to use it. And so I got a boost of now I got a boost of over 4 times the standard speed. So it was like 12 FPS, and right now it's running over 50.
Wow. Okay, 4 times.
Yeah, 4 times that I got the boost. I did a lot of optimizations, and it's working great. Mm-hmm. But I did that for Vibe. Okay, I can do that for others. I was talking to Mike, and he asked me to do for the other background protections. Also, I can do that, mm-hmm. And I can also make this Vibe code and then try to implement it on one of the other libraries that we have, like BGS or anything like this. Mm-hmm. So we can now use it.
Can you give an idea?
The first thing I did was.
Yeah, sorry.
No, go ahead.
My question would be, how much work is it, a transformation of one background? So as you did it for Vibe, how much work was it actually? How long did it take you to?
It takes a couple of time. It takes some time, mm-hmm. for because it's optimization is a process it's a step-by-step process. Mm-hmm. I first look at the algorithm itself, and then I look at some of the code optimization that I can do. That's a very straightforward, and then from that I just move on. I can do that for any algorithm that we decide to use or decide to test. Mm-hmm. The first thing that we need to do first is to decide one algorithm for background subtraction. Then, of course, we have to test a lot of them. So it'd be good to see the performance of the best one, mm-hmm. and then we can go for the best one. I can squeeze the performance of that code as much as we need. But I can implement this Vibe one. I can implement on anywhere that we need.
Okay, so your first implementation is the one with Vibe. You implemented it on a Pi, as I read correctly.
I implemented as a code that we can run anywhere. So it's a small library that has a class in C++, and you just call the class and pass the OpenCV image there, and it will process and return another image with the mask. That's it.
Okay.
It's very easy. The code is on our repository. Anyone can look at it. So it's just to understand it, it's very easy to understand. It's very easy to use, and I can port it to anywhere else that we need.
So okay, if you, I think Mike and you are going to test several other background subtractions. I think it doesn't make sense to optimize every one of them, or does it?
Yes. No. I think as Jonas said, I think the best thing for us to do right now is to select the one that has the best performance quality that we need. What I mean is that the most important thing for the project is to have a good background subtractor, one that works for us, and that can track anything that we need. So we need to decide an algorithm, but the most important thing is to select one that we have to evaluate a lot. We can just test some of the background subtractors that we are using already against this one that I implemented, the Vibe, and check to see which of them performs better and does a good job. Once we selected one algorithm, then I can just go ahead and implement more optimizations.
Okay, and the outcome is then a pure C code? How can you fathom that?
No, the outcome is right now is a C++ code. It's just C++ code, nothing more.
Yeah. Okay. So, yeah, maybe it's a stupid question, but I have to ask it. If Vibe is provided you by Pierre-Luc in, let's say, Python, how do you transcribe it into C?
If someone provide me an algorithm in Python, I can code that in C also. That's okay. I can translate.
Yeah. Sorry, can I just quickly jump in there? It wasn't provided in Python, Richard. It was a C++ module that Pierre-Luc provided. There are actually a couple of other background subtractors in the library, one of his libraries as well. So there's potentially quite a lot of testing that we could be doing over the next couple of weeks just to see which is best for our situation.
Yeah, perfect.
But yeah, my question was directed in this. If it's a C++ library, then of course, it makes performance enhancements easier. But if the library is based on Python, that would be a huge workload, wouldn't it?
No, most of the libraries for background subtractor are in C or C++. And then we have and then we have a wrapper that exports this library to Python that you can use.
I see. Okay.
So
I didn't know
from Python we can call a code in C++.
Yeah. Okay. Yeah, when it's wrapped.
Think of Python as just the scripting language for C, as the object-oriented path is C++. So it's just an extension to have the scripting capabilities. So Python is the scripting capability to C.
Yeah.
C and C++ do the heavy lifting, the hard work, and taking care of memory management and things like that. And then the wrapper will take care of the results. The Python wrapper will take care of the results and transfer it wherever it needs to go, if that makes sense.
Yes.
And I do understand that most background subtractors are provided in C or C++, right?
Yes.
That's what I learned today. Okay, thank you. Any topic that you want to raise? Any one of you? Development topic. A problem you're stuck in, help you need, a question you have? Okay. Silence. Okay. Just a note on the side, because I have it here on my page, is Tommy Goodson was so kind as to inform me today, or yesterday, that he will provide a $40 discount on the QHY193C cameras for the US market since yesterday. So thank you very much, Tommy, for this great discount. And just information for all of you, if you are going to invest in a camera, that's the right way to do it, because you get it much cheaper here in the US than in Europe.
I'm hoping we can get it cheaper. Supposed to hear back from them tonight on whether or not they can. They said that if we want to do something simpler with the camera, they would get it cheaper to us. So I said, okay, take the software away and just give us the RAW. So I'm waiting to hear back from them on that.
Okay. Did you see my comment to you, Tommy, on that?
Yeah, I did. I did respond to it. Just I'll respond to it. I'll explain to you later.
Okay. You want to do it?
Yeah, but I'll explain why.
Okay, yeah, sounds good.
All right. Charlie, any question up to now? Mr. Charles Gibson?
Oh, I'm sorry. I was taking notes there.
Okay. I was just asking in between any questions up to now.
I appreciate that. I don't have any questions on the development phase, so I'll stay out of the conversation right now.
Okay.
Perhaps before we end the conversation, I could present to you three of our community's questions that they have concerns about. So just keep me in mind before we finish up today.
We can go into your question. Just shoot them.
Oh, okay.
Absolutely.
I just didn't want to interrupt the flow. One of the questions that's been presented to me is, will there be permissions for using non-local devices? I guess another way to put that would be, if I'm sitting here in Kansas, would I be able to join a platform in, let's say, California? Would the administrator of that device be able to give me permission to view his machine non-locally? Does that make any sense?
If the question makes sense to me. I'd say it's a simple, okay. For now, this year, we focus on local stations, meaning the station acts as a local node and creates its data, and the data is local on the station. And if you are in the same network as the station is, then you will have access to the data. You can also, if you are remote away, you can route your network so that you have access to make a VPN and whatever have you. In the future, next year, we will go for a centralized storage. There are several ideas, and we discussed today, Christian, again about it. But this is something that it's a huge project by itself, and we postpone it into the future because we have other topics to solve for now. But the idea is then that all the data from a station is generated live, is stored there centrally. So we have, let's say, a local running storage, because locally you have, let's say, 1 terabyte, and this is always filled up. And old ones are renewed with the new events going on. But every event is also stored centrally. So you only have a rolling storage locally. In this case, you will also, so not only if you're in the local network have access to your data, you will also have global access to the centralized data that will certainly be provided. That's the idea of the whole project.
Understood. That sounds fantastic. I guess my next question and priority would be the graphics user interface. Some are concerned that it may be too complicated They may have to learn how to use machine language or something like that to operate the equipment. So is the graphic user interface something that's going to be user-friendly where an average person will be able to do it, or is that something that will be need to be refined as it goes?
Rebecca.
It's going to be user-friendly. It's going to be a web page with self-explanatory text on there. It's going to be very simple to use. You'll be able to from there decide what you want displayed. If you want ADSB software data displayed from your Sky 360 station, or if you want an online API with flight data displayed. So it'll be as simple as clicking a button and that will be rendered for you. So it's going to be very simple. Just you won't need to know any coding or anything like that. I anticipate the hardest thing that a person will have to do is go to some of the online API sites and request a key, so that way they can cut and paste that key into the GUI, into an input box in the GUI. But I think that's probably the hardest thing that's going to be done. In the future, for example, if they want to move the PTZ camera manually, we would have something set up so that it could be done from the GUI directly, sort of like a video game. So I think that might be the next hardest thing, is the user manually moving equipment via the GUI. So no, it's going to be very simple, very easy, very intuitive. You're not going to have to really know how to do anything except know what it is you're installing. But we kind of expect users to have some sort of, we would expect users to have knowledge of what they're doing because they're putting the system together. So we're not assuming the most simple user out there. We know users with some knowledge, but you won't need to really know how to do any coding. I think at most doing the Docker build from the command line might be the most difficult thing. And that can just be worded in a simple how-to guide for someone to do. So
fantastic. Well,
clarify. I want to add to that, Charlie. So for me, having something simple is actually very complex to do. Okay, the more simple it is the more complex. So, exactly. But what I'll ask from you, because simple has ambiguity in it, if you can ask the people in your community what they expect, what kind of feature they have in mind, that will help us a lot also, because that will give us feedback of what they are thinking of, what they want to see, maybe first even. So that will help us also with prioritization, I suspect.
I will investigate and see what their concerns are. Okay. Considering the API aspect, am I correct? Am I correct in assuming, let's say an event occurred that was captured on the unit? Could a person go immediately to, let's say, the aircraft control or aircraft flight survey models and get information on what is in the sky at that very moment? Am I understanding that's what that is?
It should be part of the event that you will receive also. Maybe not in the alpha version, but later on it will be part of the event.
Okay.
Like the event, think about the event should have everything that you need to know on that event that happened, including all the data from all the sensors, all the everything. Okay, it's for you to make the decision as fast as possible.
Every event is going to be stored per that event. So, it's going to have its own label and it's going to have all the associated data with it. Everything from the sensors plus the video feed, all of that, and put under one label. So that way people can recall it in the camera. And the goal is to make you be able to replay the video feed in the camera and replay all the sensor data in the GUI itself.
Yeah.
A reenactment.
That's a fantastic option. I really like that. My people are going to love that aspect of it. I guess the last question.
The beauty of real-time system and recording and replay. Yeah.
May I interrupt, Charlie, on that note? I share my screen just to give you a glimpse of the user interface. It's just a design, a raw design, but it might give you an idea. Hold on a second. That one. Do you see my screen?
Yes.
It's asked me to accept. There we go. Yeah.
Okay.
All right, now I got it.
So what you see is, so there's a menu, and yes, I'm not going into deep. On the left side, you see a fisheye view. It's just a design idea. Okay, this is not a real user interface. So on the left side, there's the fisheye, and with the north-south compass indicators. And there you will see the live feed of the camera. And what you also have here are tools that go along with that feed. For example, you can pause it, you can play it backwards, you can screenshot it, you can maximize it. But there's also a little hamburger menu, and the idea is to give you overlays. And the overlays can be of several sources. So for example, is either a built-in ADS-B sensor that gives you local real-time ADS-B messages and projects the results directly over the live feed. So in this case, if you see, for example, a plane, let's assume the little star that is with a green rectangle is an airplane. In that case, you would immediately see also the parameters that comes from ADS-B, from your ADS-B sensor. And if you do not have a local ADS-B sensor built in, then you have the option to retrieve ADS-B service either directly from FlightAware, or that's an option we have to collect it in between somehow, because I think FlightAware is bound to a fee, a monthly fee or so. On the right side, you see other sensors. There are, let's say, motion detection sensors and let's say the pan-tilt zoom camera. So I'm stopping it again. So the idea is, it's just like a computer game. You have an interface and you have your buttons, and just click them and select what you want to see. And all events are automatically recorded, so you do not have to press a button for recording, right? But there will be a feature in the future, not in the alpha, which allows the user to override the automatic process and hit, let's say, a record button, because maybe there's something in the sky that she wants to have recorded anyways, no matter what the software tells. Could be.
Sorry, you dropped out. Yeah, you dropped out there a little bit. Absolutely, man, this is fantastic. You guys have thought of everything, more options that I even then could come up with. So yeah, I like that feature. Because a lot of this is going to be about proving what you've seen. There's you want to get all the data you can. Maps, air traffic, anything that's going on simultaneously has to be part of the equation. So it sounds like you guys have thought this through a lot more than what I thought you could. So that's fantastic.
Okay. One other thing that is a future part is an app, because yes, we had hundreds of questions toward this direction. People want to have an app on their smartphone that gives them notifications. I can fathom a simple one that is only kind of a service, runs in the background and raises bubbles if there is an event, up to a full feature user interface. We'll see. But certainly there will be something in the future where the user will be notified if there is a significant event.
Fantastic. That pretty much gets all my questions answered. The rest of them are, I would say, just something that we could consider in the future. They don't represent anything that we need to know right now. So I'll stop with my questions at this point.
Perfect. Thank you, Charlie.
Christian, Richard, sorry. Around the NAP, okay? We don't really need the NAP. And here is why. There is something called today progressive web app, okay? That with a single line of code in our web, will allow, once you reach that website on the browser on your phone, it will tell you that, hey, you can install this app. And then when you install, it's actually installing a link to a browser, okay? But if we build our UI, and I spoke with Rebecca about it, responsive, then we can make it support all fonts or common fonts. So that shouldn't be too much of a problem.
Fantastic. Okay, thank you. I appreciate that. Richard, back to you.
Thank you, Charlie. Yes, and as Ido said already, if you guys come up with ideas that we did not consider yet, just raise them, and we put them in the list of ideas we want to solve in the future.
Okay.
Because we certainly have not considered everything.
Oh, and I believe there comes a time that you can consider too much. I have, everybody's asking, why isn't it out now? Can I get it now? And I keep trying to express to them that, yeah, you could probably put together a unit right now, but trust me, quality is better than quantity. I mean, you can get one right now, but if you're really wanting a usable unit, take the time to let these people go through with because it is so technologically complicated that you just cannot believe the effort that these people are putting into it. And they're only doing it because they want to release a product that is refined and the best quality that you can possibly get. And it's just going to take time to do that. So you guys are helping me with that. I need to answer these questions, and you're giving me the information to do it. You're swinging the sharp edge of the technological axe at this problem, and we all have faith that you'll get it figured out.
Thank you, Charlie. Thank you for the kind words. It is. We do understand that people, especially on the UAP society, who are not so familiar with the work that we do here, are concerned about timing and a product. When does it come up with? And there were so many projects in the past that did not come to reality and so forth. I can tell you one thing: we are here to stay. No matter how many developers we have. Christian and I decided once, Christian, please correct me if I'm wrong, that no matter, even if there's no one developer contributing, and Christian and me would be the only ones, we would still do it. Okay? Right, Christian, you remember?
Yes.
A year ago.
Yes.
Said, if we still stay the same, if we're still the two of us, then yeah, why not? Let's do it. So this is
we are not in a rush. We're not in a hurry. So since we have time, we didn't care if we stayed just the two of us, or like now have a bunch of people doing the same stuff, having someone to talk to, have nice discussions, go through ups and downs together. Yeah, it's a gift, and I have to say I'm pleased to be part of it. And even if we wouldn't have found so much nice people, we would have stayed on the project and did it by our own.
True.
Oh, I appreciate your efforts, because when I started to study this in depth, because I really wanted to know about the system. Honestly, I've been watching the sky for 40 years, and we could only dream about a system that would, a robot that would watch the stars and inform you when something happens, and then zoom in on it with 40x power and start collecting data. That was Star Trek stuff. Well, science fiction is becoming science fact, so it's worth the wait to get this done. I had to tell you, I had notes when I was studying this. I had notes on one side of my desk referring me to notes on the other side of my desk, and it got so complicated I just had to just give up for a minute and go recoup. The technology that you guys are putting into this is just It's spatial. You guys are doing something special here. So please, even if it gets down to the two of you, keep up the work. Do not quit.
No, we certainly won't. And I have to confess, my first idea of such a system was far away from what it is now. I have to say, what you guys came up with, this robotic system, this real time, this high performance camera and processing, I did not expect that, and that's what I'm very grateful and thankful to all of you. Thankful on my English.
I think when we started in March 2020, this is when I found my way to SkyHub, and Richard and me, I think we started talking around May.
Mm-hmm.
Yeah, around May. SkyHub was in a quite different state, and I was wondering why nobody took care of the hardware and why nobody thought of doing some math about what you actually can record with that Dahua cam. And honestly, I was looking for something completely different, a way to track the ISS, because my efforts on that for being an astronomer for now 25 years now was, okay, there must be some system that can be easily used to track the ISS and make a pretty video of it with high resolution, because in astronomy you were using high resolution cameras up to 16K for quite some time now, and yeah, I came across that there is one problem for tracking the ISS. It's the accuracy that any mount of a telescope has to undergo to keep it in the middle of the image. And if you want to have a very resolved image with not only just a high resolution in pixels, but a high resolution in dynamic range, so you can see or make visible the parts of the solar panels and the modules and antennas, then you have to do much more than just have a nice resolution in X and Y. And that kept me thinking, so we needed some kind of improvement of the hardware. And from December 2020, we talked about how we can cope with it and how we can find a solution. And I think it took to May 2021 that we got the right understanding of what needs to be done. And then we got the message that SkyHub will close to the end of August. And so we took the chance and said, okay, let's start from scratch, take the things, do a revision, and do it right. Yes, and we didn't set, okay, these surroundings must be met so we can keep on. We just said, okay, we go on with it no matter what. And you see the result for yourself.
Yes. Excuse me. I understand exactly. I can't remember how many times we'd have, let's say, the Schmidt Cassegrain tracking a star, and something would occur and just outside the field of vision. And it's like, wow, if we could immediately slew and capture onto that. But that's as far as we ever got. It was just in dreams. You guys are making it possible. You jumped both feet in the fire. I had to admit, I don't know of anybody that would take, put so much effort into something that almost seemed impossible to do. So, I'll pass this on. I'll pass this on to our listeners, and they'll be impressed.
I have a funny thought, let's say. I think that most military on this planet won't have a system like that.
Oh, they do. They do.
Because they buy from Israel.
They have the power of tracking an object, yes, but not for the resolution in any kind.
Yeah.
Because on the one hand, they are based on video, and video just does 8 bits. So per channel, you've got 250 shades of gray. And in astronomy, the cameras provide up to 16 bits, scaled to 16-bit with 65,536 shades of gray per channel, which increases the data to max.
Wow.
So you have got not only the dimension, let's say 16K for the camera, 16 megapixels, but the resolution in the color depth too, and this makes it so much more, because you can have time series for some kind of analysis that any visible object that doesn't have any cloak on can be recorded with it and analyzed with scientific methods, and this is the improvement that Sky 360 can provide. And the military don't have that, but they may be inspired by what we have, and maybe take along the ideas that we come up with. So yes, we can have an influence there too.
It's pioneering work.
Yes.
I remember back when. Go ahead.
I was say, get the military to donate a honorara to the project. For using the technology.
Yeah, exactly.
Wouldn't that be fantastic? I remember back when it was 1.2 megapixels, 3.75 micron, 1280 by 960, and the data load was so much that our, I believe it was like Windows 10 or whatever it was, couldn't even keep up with it. So using the technology that we have now, we will be able to identify things that we only had dreamt about in the past and use it and record the data and pass it on to others that may be interested in it, to use it in a completely different manner than we can't even imagine at the moment. So, yeah, the military ought to get on board with this. Would there be a funding consideration there? Because you are a... how do you say?
NGO, non-growth.
You're not a corporation. You're, so how would that work out?
There certainly
well, that's why I said donate to the project.
Be money from any government to us, because we have to stay independent. So yes,
correct.
They can copy us. I mean, we are open source. Anyone can copy us. Everything is published. So yes, they can do. I'd like to see a Sky 360 mentioning somewhere, maybe. But money, I don't care.
There you go. Well, it's all about open source. Everything has been so secretive that the right hand does not know what the left hand's doing. And the only way we're going to overcome this obstacle is if people start sharing their information openly and quit trying to make a profit off from it, because that's when the system breaks down.
True.
Yeah, we have to shift the paradigm of profit a little bit from money to knowledge and capabilities, and this is what we're doing here also. So I think it is worth doing it in open source, because what we're doing can't be valued in a certain amount of money. And if we would do that, if we say, okay, we're just doing it for the money, prices will increase, and we would have our part in increasing those prices. I think it's the opposite that we should do, because we do it for free and with best interest. That will lower the prices in the future.
That seems to run parallel with Chris Leto's understanding of how the system should work, and that's what he preaches on the UAP Society's forum. We have to make this available We can't expect other people to do it for us. Let's jump in, get behind this 360 project, because this is where we need to go. So with that, I'm going to jump out of the conversation, and with many thanks to all of you for helping me out with this. This, like I said, the word is out. People want to know, and I think you will be surprised on how many people get behind you on this. So with that, I thank you.
Thank you very much, Charlie, for your kind words. And as we already said, we are here to stay, and we have a big goal, and it takes years to be there. But we still hope to have a rollout, let's say by end of this year, beginning of next year. A rollout in a way that someone can purchase hardware, because we are almost settled with hardware decisions right now, I assume, for now. Software has to be finished, finalized, and I think we have hardware outside, so there are already people who testing hardware, building it up. But for a community to purchase equipment, so that we recommend, and that's our responsibility here. So we do not recommend anyone starting doing an implementation, besides he or she considers himself as a beta tester. So be aware that the system, until it is in productive version, will not be a productive system as expected it to be. So let's say until it is a productive system, it will be a beta system, a test system, and a development system. So anyone who jumps in and starts purchasing equipment has to consider that everything is in development, and it can happen that hardware can change as it did in the past, but we try to support as much from that hardware as possible. So we still try to support the Jetson family. We hope to use CUDA in the future as well. So all the stuff that people already have purchased shall be supported somehow in the future. We try to take care of that. But if I would talk to your whole audience at UAP Society, I would say please hold your money tight and wait until the productive version is out. Besides, you're not considering yourself as a co-developer with us. Then you can jump
Understood.
Forward, of course.
If I remember right, I read in one of your abstracts, or I can't remember what document it was, that there would be perhaps like 4 levels of build, where you could have a unit, a standalone unit that records the data and is retrievable to your computer through, let's say, a USB, or one that is hooked to the internet. I believe there was 4 different levels of build. Is that still your goal?
We think of 3 levels of build. And it is not meant in functionality, but more in extension of hardware, more sensors, bigger sensors, expensive sensors. So the idea is, and I have to rework the create list of hardware so that the tiers, what the idea behind the tiers is better represented. So the idea is to start with a tier 1 and invest, let's say, up to $1,500. And then, let's say a year later, you go into tier 2 and you invest more $1,500. So you have a final of $3,000. And the tier 3 is fully equipped with passive radar and what have you, tons of antenna, and that should be below the 5,000. You can, of course, immediately then go into the 5,000 range, start with tier 3, let's say, when we are there, by development. And you have to decide for yourself. Do you enter at tier 1 or tier 2 already, or you wait until you have a better budget for the next year and so forth? Because we see this project as a grassrooting effort, a citizen science effort, where we create open source data with people who invest their own time and money and build up their own station to contribute to humanity, basically. And our effort is to develop this and to provide a great list of hardware. What do I want to say?
I think also that's like a perfect example of how multi-layered and intricate intricate this project is, because the 4 levels that he was referring to are what I wrote from the perspective of the GUI.
Okay, sorry.
It's not. Yeah, you're talking about. Richard is talking about the different price levels of hardware. I was talking about from the perspective of the GUI. Some stations will have only the camera and no internet. And when I mean no internet, they're not going to be able to get anything from hardware devices that would receive information from the internet or from API. And then a different level where you have API information only, because they haven't purchased the hardware yet. They're still leveling up and purchasing hardware little by little, but they have the camera. So that's what he meant by the different levels. So it's a very, very involved project. But yeah, that's what, I don't know what your original question was about the 4 levels, but that's one aspect of 4 levels, but for the GUI, and then Richard is for the hardware, the different pricing levels on the hardware.
Yeah. Okay, now that gels. It was kind of confusing at first, but now that all gels and I understand. So fantastic. Thank you for explaining that.
Okay.
Sorry for the confusing you.
No. As long as this system is upgradable, we will have people come in, probably starting at one of the lowest levels, with the expectation of building up. However, we do have people with money. They want to spend. They're out there. Money is no object. They want to be on the cutting edge. So the spectrum runs from the person that has $1,000 to invest to the person that just doesn't care how much it costs. He has to have that technology. But I believe the foundation will be built off people that want to start out at a level, knowing that they will be able to grow through the process without having to start all over again, because there's nothing worse than buying a piece of equipment and finding out it's obsolete as soon as you get it. So as long as that understanding is made perfectly clear that no matter what level you start in, you will always be able to upgrade and grow with us as technology changes, that would satisfy a lot of concerns.
Yeah, that's the entire point of building it as a robotic system. So it's designed from the ground up for upgrades and extensions, right? So if like a company wants to, I don't know, develop more sensors for us, we will be able to attach them. Okay. But I'm speaking like future.
Yes. Okay.
And I think
all right. Thank you, guys.
One last note. I think the element of the do-it-yourself is a very crucial one, because we'd like to set up this network of 150,000 stations, and we thought the only way to make that, to become that a reality, is via the people. So we cannot finance this because that would go into the billions, but people out there investing their private money to be part of a bigger network, that is the way to do it. And because it is the way to do it, the do-it-yourself is very crucial. So everyone should be able, even if someone says, I have 2 left hands and I cannot use a screwdriver, but at least the system is able to be built by lay persons. So if you are able to use a screwdriver, you should be able to build this system. Okay. So that's the let's say the basic do-it-yourself idea. And yes, there are people with money and they just want to purchase a station. And I think because we develop it and have that always in mind, this do-it-yourself, there will be people in the future who will provide fully functional stations for sale or produce on demand. For example, Tommy, correct me if I'm wrong, we already discussed in this route already. So maybe in the future that could be a business for someone to prepare those stations for someone who just wants to invest money and not tinker around in the garage.
Yeah. Also, Charles, I would add that in the future, I happen to have that exact plot in mind. So basically, there's a whole backstory there. I don't want to get into it because it's not directly related. But as a future thing, like after that sort of thing, I'm definitely going to be interested in being able to provide that kind of service, and I would basically do it at cost because part of the plot there is I'm working on setting up a 501c3 here in the U.S. that I see, helping Richard and Ambrose roll out the Western U.S. part of the network. I'm all for that, and it's, what do I do to help? Just you might just quick note. As things go forward here, I would be very interested in helping out in that regard. So just for future reference.
That's all hands on board. All hands on board solving a problem. That's wonderful.
Yeah, and the problem, please, guys, keep that in mind, is not US based only. We are global. Okay.
Yes.
If we find someone who does it for the US, that's nice. But my position is I have to find it for the whole planet, So if we set up this as a new project then in the future, then we have to keep that in mind. We need this for any place on this planet. So, and it's nice that we have so many people from the US offering this service, but yes, I also need it for Africa,
planet is under fire, so we need to do something.
Yeah, true.
And I am willing to travel.
Okay, we live in wonderful times. Carl Sagan once said, of all the creatures to have had inhabited the earth, we are the first to truly see the stars. I think we're going to start seeing things that we haven't been able to imagine yet. So I'm bowing out. I got notes full that I'm going to have to go through. Again, thank you all. Thank you so much to all.
You know what? The dinosaurs is vanished because they become very big and angry and whatever, and then somebody just clean out. And like humans now, we got bigger and bigger, and somebody got just clean out humans from the earth.
Yeah, I hope you're not right.
I am right.
Well, we just concluded the DART project. We're in the process of saving humanity. God help us all.
Amen. So on that note, I may close the session and stop recording.